Today, let's start the discussion about space technology. Okay. Before that, let's discuss some science questions from last prelims. Okay. There are nearly 16 questions, nearly 7, 8 directly from science, few are from current affairs part. Okay. Just go through question. First one, consider the following types of vehicles. Consider the following type of vehicles. First one, full battery electric EV, normal electric car, bike. Then hydrogen fuel cell, where the fuel is hydrogen. Hydrogen, is it more polluting, less polluting, or no pollution? Hydrogen fuel. It is the cleanest burning fuel. Cleanest, not the cleaner, cleanest. No carbon emission, zero carbon footprint, hydrogen. It will produce water vapor. It will produce water vapor, no carbon dioxide. Okay. Hydrogen fuel cell. Then fuel cell electric hybrid. Fuel cell electric hybrid. In Singapore, Malaysia, I forgot the country. Recently, there was a video regarding Hyundai's new car named Nexo. Hyundai's new car named Nexo, not Nexon, Nexo. It is a fuel cell electric hybrid vehicle where hydrogen fuel cell is there. Hydrogen fuel cell, which produces energy. That energy is converted into electrical energy. Later, the EV mechanism will run the vehicle. Combined hybrid module. Just Google, not right now, later after the class, Hyundai Nexo. You will get to see the video how it will emit water, right? Now the question is, how many of the above are considered alternative powertrain vehicles when compared to normal diesel, petrol, compressed natural gas powertrain which we have? Which among these are considered as alternative powertrain vehicle? They're asking. What? The answer is there itself. By seeing the question, you should know about the future technologies. Hydrogen fuel cell, right? Hydrogen fuel cell and electric hybrid technology. What does that mean? Okay. Electrochemistry part will cover, where we will discuss about the different types of batteries, cathode, anode, how electrolyte helps in the transfer of electrons, etc. We'll discuss. Here, all three are correct. All three have alternative powertrain when compared to the normal ones. Then, with reference to unmanned aerial vehicle, UAV, unmanned aerial vehicle means, yes, kind of drone, but not exactly the drone, right? If I say drone, the first thing comes to your mind is the drone which is used to capture the normal video, etc., right? With four motors, etc. But that is also a drone. There are very other sorts of drone available. For example, India's medium altitude long endurance drone. See, this is our DRDO's Rustum 2. It's a kind of a radar system which helps to detect enemy aerial vehicles, enemy fighter jet, enemy helicopter, etc. It is there to detect. It will be flying for nearly 20 hours continuously without or with our control. It can fly autonomously also. It can be controlled by the ground station also. Rustum. This is also a drone. Will this kind of structure comes to your mind when you think about drone? No, right? This kind of structure comes means you generally think this is an unmanned plane, unmanned helicopter kind of thing, right? Unmanned aerial vehicle means without human, the flying object, that's it. Now the question is, with reference to unmanned aerial vehicle, consider the following. Consider the following statements. All unmanned aerial vehicles can do vertical landing. All unmanned aerial vehicles can do vertical landing. Vertical landing means straight. In wedding and other functions, the photographer, the drone operator will make the drone to land on his hand vertically, right? Do you think the Rustum 2, which we have just seen, will land like that? No, it will land like an aeroplane, right? So, first statement is wrong. All unmanned aerial vehicles cannot do vertical landing. Then, all unmanned aerial vehicles can hover. Hovering means flying in a particular place, point, means it is not moving, it is just staying at this point for some time. While capturing the video, the drone will be hovering, right? That cannot be in each and every drone. That is also not true. Then, all unmanned aerial vehicles use only batteries for power. This is kind of general knowledge question, which we should be knowing. Once you read about the drones which we use in defense, etc., you will be knowing what all the. Have you seen the drone which Drone Pratap use? Drone Arc Aerospace, the bigger drones to sprinkle pesticides, etc., right? That uses petrol, diesel, etc., fuel, petrol usually, right? So, all drones are only battery powered is wrong statement. So, here, how many of the above statements are correct? None. No statement is correct. All the statements are wrong. In the context of electric vehicle batteries, consider the following elements: cobalt, graphite, lithium, nickel. How many of the above usually make up batteries cathode? EV is the future, right? Electric vehicles. You need to know more about the raw materials required for the manufacturing of battery. Then where are the major resources available in the world? Then later in the cathode, anode, which are all the elements that can be used, and how the normal dry battery works and lead acid battery works, you should know. We will discuss in electrochemistry part. Here, the normal battery which we use in the EV vehicles is in our mobile phone is, which battery do we use in our mobile phone? A lithium ion battery. Li-ion. L-I-I-O-N. It used to be written on your mobile phone's battery. Lithium ion battery or lithium ion polymer battery. Okay, lithium based battery, which we generally use these days. Cobalt can also be used as a cathode. Lithium is 100% it is used. Nickel cadmium, nickel can be used. Graphite is also used in the battery. Graphite is also used in the battery, but it is not used as a cathode. It is being used as a anode. Cathode positive or negative? Anode cation positive, cathode negative, right? Cation positive, cathode negative. Okay. Here, graphite is used in the anode, not in the cathode. For you to know the list that deeper, you should be knowing about how the battery works, what is cathode, anode, electrolyte, how electrons will be excited, how it will flow through the electrons, etc. We'll discuss. Here, see, three options are correct. One is cobalt, lithium, nickel are correct. Graphite is not used in the cathode of the battery. Consider the following: cigarette butt, then eyeglass lenses, car tire. How many of above contain plastic? One, two, three, none. What do you think? Even cigarette butt contains a microplastic polymer. Okay, that also contains a microplastic. So here all three are correct. All three. Eyeglass lenses, it is not a complete glass. It's a glass polymer fiber kind of thing. So all three are correct. All three. C. All three are correct. Then consider the following substances: ethanol, nitroglycerin, urea. Coal gasification technology can be used to produce how many of the above? Converting solid coal into gaseous fuel, coal gasification. Here majorly ethanol and urea are released. Ethanol and urea. Nitroglycerin not related to this. Nitroglycerin is an explosive material. Nitroglycerin, explosive material, but it is not released here. Coal gasification. B, two are correct. Ethanol and urea. What is common to Cl20, HMX, LLM 105? It was in news. The refrigerant alternatives. Actually, earlier, once upon a time, we used to use chlorofluorocarbon as a refrigerant, CFC. Do you know? Chlorofluorocarbon. Later, based on the research and experience, they got to know CFC will cause ozone depletion. Chlorofluorocarbon will cause ozone layer depletion. That's why they have replaced CFC with other alternatives. But that is not the answer here. Where exactly ozone layer is present? In our troposphere, stratosphere, mesosphere, thermosphere, exosphere. Where? Troposphere means the layer which we are living in right now. Ozone is not here, right? It's in the next layer, stratosphere. Stratosphere, right? What might be the thickness of ozone layer? First option, ozone layer thickness 3,576 kilometer thickness. Okay. Second option, 353 kilometer. Next option, 3 millimeter. Next option, 300 centimeter. 3,000 change kilometer, 300 change kilometer, 3 millimeter, 300 centimeter. What will you choose? B. It might be some kilometers, right? Actually, ozone layer thickness is measured in Dobson units. Dobson. Okay. Ozone layer thickness is 300 Dobson. 300 Dobson means only 3 millimeter. Just imagine how thin the ozone layer is. Ozone layer is made up of? Made up of what? Which gas? No, 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 no. Ozone is nothing but O3. Single O means monoxide. O2 means oxygen. O3 means ozone. O3. How ozone layer helps us? What it will do? UV rays. Not exactly sunlight, UV rays. Right? The two harmful UV rays. Ozone layer protect us from harmful UV rays. In the UV rays, there are UVA light, UVB light, UVC light, ABC. C is more harmful. Okay, B less harmful. In one examination, they have asked a child with improper bone growth. A child with improper bone growth. Doctor suggested to stay outside under the sun for longer duration every day. Which ray of sunlight helps in the bone growth? They have asked. Doctor suggested a child to stay in the sun to get vitamin D. Which rays of sunlight will help the child to get vitamin D? Options are visible light, infrared rays, ultraviolet light, then all of the above. What you will choose? Visible light means the light which helps us to see things around us. Infrared rays means the heat. Infrared rays. Simply we can say. Then the ultraviolet rays. Then all of the above. What you will choose? Choose anyone. That's fine. ಹೇಳಿ ಪರವಾಗಿಲ್ಲ. All of the above. See, the common easy option which we have is all of the above or none of the above, right? That will be correct sometimes. I'm not telling that's wrong, but here the answer is ultraviolet light. Not the harmful UV light. Useful UV light, UVB rays are used here. Sunlight does not contain vitamin D directly. Sunlight will not have vitamin D directly. What it will do, the ultraviolet ray, UVB rays falls on our skin, right? Underneath our skin, we have fat stored in adipose tissue. The fat tissues will be burnt. Means it will be converted into vitamin D form. By the conversion of fat into vitamin D, we will get vitamin D. Sunlight will not directly give us vitamin D. But what do we generally say? From the help of sunlight, we are getting vitamin D, but not in the direct form. Okay. Not exactly, actually. UV right helps actually. Here, CL20, HMX, LLM, etc. are serious, high capacity explosives. They are the explosives here. Explosives used in our defense. Explosives. Consider the following statements. It was in news, current affairs. Majorana 1 will enable quantum computing. Quantum computer means, see, the computers which we are generally using right now for internet browsing and to do MS Word, Office, Excel jobs, that is less capacity. What is the cost of your laptop? 50,000, 70,000, 1 lakh maximum, right? Generally, the range 40, 50,000 rupees for general use, right? All these laptops, computers, desktop, which we are using for basic use, those are called as microcomputers. Not because of the size, because of the capacity. Then we have mini computer. Mini computer means for designing, graphic designing, etc. We need more RAM. We need more graphic card capacity, right? The cost will be little higher. Those type of computers, mini computers. Then we have the computers which are connected to the server, which can give service to lakhs, crores of customers. That kind of computer is called as mainframe computer. For example, I browse, search something on YouTube. I'll get the video, right? The computer which is being connected to the YouTube server, that computer is called as mainframe computer. Then we have supercomputers. Supercomputer. Do you know? Have you heard the name supercomputer at least? Supercomputers will be of the size of this building. Just imagine. Generally, the first thing comes to our mind when I say computer is a desktop, keyboard in the front, mouse, then a CPU, right? That is not only the computer. Even your calculator is a computer. Your speedometer is a computer. Computing device means what? It takes data, right? Raw form data. It will process the data and it will convert it into useful information. Converting data into useful information. The device is a computer, computing device, right? What supercomputer will do? It will be very huge. It will be placed in big buildings with good ventilation, air conditioning. Supercomputers, simply, if you check Google weather report here, it will show today's maximum and minimum temperature in this area, right? MCHS layout, some layout, right? If you move to the adjacent layout, the values will change. Next layout, values will change. In Bangalore itself, you will be getting on 10,000, 1 lakh, at least thousands of values, right? In South Karnataka, in South India, crores of values you get for each and every region. By computing, by combining all these values, you should get a single result. What is weather like in south of India? That result, that much amount of calculation for a computer to be called as a supercomputer, for a computer to be called as a supercomputer, it should be doing 1 followed by 15 zeros. Just imagine 1 followed by 15 zeros. 1 crore means 70. 1 lakh crore means 12 zero. Trillion. More than that. 1 followed by 15 zeros. Petaflops. That much operation it will do in 1 second. 1 followed by 15 zero operations in 1 second. 1 second. That is the basic capacity of the supercomputer. That much operations it can do in a single second. Supercomputers are majorly used in nuclear research, weather observation, weather forecasting, then fluid dynamics calculations, etc. So many fields they'll be using. Every year, twice, global ranking of world's fastest supercomputer will come. In the month of November, it will come. This month, global ranking, top 500 supercomputers in the world. Right now, world's fastest supercomputer is El Capitan from USA. El Capitan, right? But it will change, don't write. It will change this month, it will change. By the time of examination, it might change once more. Okay. Right now, India's fastest supercomputer is in the global ranking of number 75. Earlier, before 2010-14, not even a single computer was there in top 500 list. Not even a single computer. Right now, we have 3, 4, 5 computers in top 500 list at least. One computer which came in the top 100 list, that is Airavat. Airavat. We discussed in detail about supercomputer. In a computer, the basic unit of measurement is bit. The basic amount of data computer can understand is bit. Do you know the computer memory measurements? Say, to measure the distance, we use millimeter, centimeter, meter, kilometer, etc. Right? Likewise, to measure the weight, we use gram, kilogram, ton, quintal, etc. Right? Likewise, to measure computer memory units, you might have heard KB, GB, MB, kilobyte, megabyte, gigabyte, right? Likewise, the smallest unit of computer memory is bit. 1 bit is equals to 0 or 1. Computer can understand only this basic 0 or 1. Yes or no, true or false, that's it. 0 or 1. Then 1 byte, this is the SI unit of computer memory. 1 byte means 8 bit. Likewise, 1 kilobyte means 1024 byte. 1 megabyte means 1024 kilobyte. Likewise, we have kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte, zettabyte, yottabyte, brontobyte, geobyte, etc. We'll see later. Have you seen the movie Endiran, Chitty, Robot? Rajnikant's robot movie. In that movie, in the starting phase, that robot used to introduce itself by telling, "My name is Chitty, capacity some terabytes, speed some zettabytes," right? That is the unit of computer memory. Okay. Here in quantum computers, the basic unit of measurement is not bit. Not bit. Here, the basic unit of measurement is qubits. We'll discuss qubits, quantum computer. The first statement, Majorana one chip will enable quantum computing. Yes, that's correct. That's correct. Then, Majorana one chip is developed by Amazon Web Services, AWS company. Actually, this is not true. It is being developed by Microsoft company. Just imagine how much amount of knowledge or information, not knowledge, let's say, information you should be having regarding a single topic of current affair. On any one day of your year of preparation, a news will come telling that there is a new chip which will help in quantum computing. Quantum computing is the future technology. That is very important. Okay. Future technology. Quantum computer. All quantum computers of the world right now are in the experimental development testing phase. Okay. Very important technology for the future. Quantum computers. That's why they have asked this question. Once you see the current affair content, you should be knowing whether this topic is that much important so that examiner will ask in the preliminary examination. That much understanding, gauging will come by experience. by experience of reading, then solving the previous year question papers. Then you will get to know what kind of question will arise, what level of depth of question they will ask, right? Who developed this? Microsoft company, not AWS company. Later, deep learning is a subset of machine learning. That's correct. So the answer 1 and 3 are correct. 1 and 3. Then next one. With reference to monoclonal antibodies. With reference to monoclonal antibodies, consider the following statements. Do you know what antibody is? In a class, we have discussed what does antigen, antibody, antibiotic, and vaccine means. Antigen means which will stimulate. Antigen will stimulate your defense mechanism. Antibodies are the response which are being produced by your defense mechanism. Antigen stimulation, antibody, the response produced in your body. If this antigen antibody stimulation and response is proper, there is no need of any medicine. If this thing works properly, each and every virus disease will be killed. Bacteria will be killed easily with the defense which you have. If not, what will happen? You will get the fever, disease, you will suffer. Later, you will go to the doctor and you will get antibiotic medicine. Antibiotic medicine. Here, monoclonal antibody, consider the following statements. They are man-made proteins. Yes, 100%. They bind to specific antigen to stimulate immune function. If they are man-made means the monoclonal antibodies, yes, they will stimulate our immune function. That's true. They are used for viral infections such as Nipah virus. Yes, all three are correct. It can be used for other viral diseases also, but it was being used for the Nipah virus. All are correct. Consider the following statements. No virus can survive in the ocean. Do you know what virus is? Virus is a unicellular, multicellular, non-cellular entity. What is the answer? Unicellular, one cell, multicellular, many cell, non-cellular, no cell. Viruses? Virus is a very special parasite. Parasite means which depends on other organisms for food and shelter. Parasite, paravalambi. Okay. Viruses are non-cellular entity. They don't contain any cell. No cell at all. Then how the structure is? Virus is made up of a protein shell called a capsid. Inside the capsid, either DNA or RNA are present. Either DNA or RNA. When we discussed about the diseases, we have discussed in viral diseases, we have RNA virus, DNA virus. RNA virus, coronavirus, HIV virus, etc. Viruses are non-cellular. They don't have any cell. Here, first one. No virus can survive in the ocean. There are millions, trillions of viruses which only live in the ocean. So that's a wrong statement. No virus can infect a bacteria. The answer is already here. That is also wrong. See, virus which infect the bacteria is called as, I have written the diagram that it looks like a robo kind of thing. This is called as bacteriophage. The name says bacteria, but it is not a bacteria, it's a virus. Virus which affects the bacteria called as bacteriophage. Bacteriophage. Okay. See, why it is important for you to cover class 6 to 12 NCERT is all these basic things: what is virus, what is its shape, how it works, which organisms it will infect, which it will not, etc. All these things are there itself. Without even studying this topic, just by the previous knowledge, you can answer, you should answer that kind of question. This is okay. So from now on, not only science and technology, each and every subject, make a plan to allot at least 30 minutes to 1 hour per day, 1 or 2 chapters per day. Start with that. Later, you can increase the time duration and the number of chapters. Try to cover NCERT books, each and every subject. It will be like a story, reading history and other subject books, polity on, that's also like a story, so that you will enjoy. It's like reading a storybook, but that's very much required for the examination point of view. First statement wrong, second statement wrong, because virus can infect a bacteria. That kind of virus is called as bacteriophage. Bacteriophage. Then, no virus can change the cellular transcriptional activity in host cell. The size of the virus is nanoscale. It can enter our cell. Our size of the size of our cell is micro. It can make such changes, virus. So that is also wrong. So all the statements given here are wrong regarding to virus. Next one. Consider the following statement regarding activated carbon. Have you heard about activated carbon? The new Garnier Men face wash with activated charcoal carbon, you might have heard. Not only that brand, many brands. Activated charcoal, activated carbon. The advertisement, what they will show, a black carbon kind of thing which will attract all the oil dust from your face, right? Likewise here, consider the following statements regarding activated carbon. It is good for removing pollutants from water. Due to its large surface area, it absorbs heavy metal. It can be made from waste material with high carbon content. Which of the above correctly explains statement 1? They already have given statement 1 is correct. They are asking you whether statement 2 and 3 both explain the first statement or only one among these two statements explain the first statement. They have given Virat Kohli is a great cricketer. Then they have given he played so many test and one-day matches and played some good knocks, winning the matches for Team India, etc. They have given. That will definitely what support the first statement, right? Likewise, here it is good for removing pollutants from water, 100% correct. Like the activated charcoal which absorbs dust and oil from your face, this will also do the same. Due to its large surface area, it absorbs heavy metal. Yes, that is also correct. Then it can be made from waste material with high carbon content. Yes, all the given statements are correct. They already have given the first statement is correct. What you need to say? Second and third statement both explain the first statement. So option A is correct. Okay. Have you seen any single question without statements? No, right? Earlier it used to be like that. Direct one-liner question, only 4 options. You need to choose among them. And later the trend changed to they used to give A, B, C, D options. Among that, you need to choose A and B are correct, B and C are correct. Later, it changed to only 3 statements are correct, only 2 statements are correct. Later, it changed to first statement is correct, which one explains it better, etc. This will also change in a year or two. You need to be ready for any change. If any change is there, that will affect everyone, right? So it's a level playing field. No need to worry. If you have the information, you should be ready to answer. The next one, consider the following statements regarding cement industry. Cement manufacturing process you should be knowing, we'll discuss. It contributes more than 5% of global carbon dioxide emission. Silica bearing clay is mixed with limestone in cement production. Limestone is converted into lime during clinker production. First statement is correct according to them. They are asking from second and third statement, which will explain statement 1 better. Here, yes, limestone and silica are the basic raw materials. That is correct. Then later, limestone converted to lime in the clinker production. Both are correct. Consider the following statements. The Earth's axis is shifting. Axis means axis of revolution around the sun. In a 400-meter track, there will be 1, 2, 3, 4, 5, 6 individual lines, right? Tracks, right? Individual track. The starting point will be different. Why? In the proper 400-meter running race, the starting points will be different, right? Why? Inner circle radius will be, distance will be less. Outer circle distance will be more. That's why the person standing in the outer circle will be in the front. In the starting point, end point will be the same for everyone, right? Here, the Earth's axis of rotation around the sun, it is being changed. The Earth's axis is shifting, it is changing the path of rotation around the sun. Then they have given solar flares and coronal mass ejections bombard the Earth's upper atmosphere. Solar flare means from the outer layer of the sun, the flares. It's coming, but it will not affect, it will not come near the Earth's outer atmosphere. And coronal mass ejection. Corona, the virus. No, corona is a Latin word which means crown-like structure. Corona means crown-like structure, right? The sun's outer atmosphere, the outer layer of the sun's atmosphere, sun's outer layer is this corona, the crown-like structure. Outer glowing layer of the sun called as corona, the outer layer of the sun. Then melting polar ice is moving towards the equator. 2 and 3 explain one, 2 and 3, but only one explains one. Only one explains one. Neither 2 or 3. Actually, here, all the given 3 statements are comparatively right, correct. But only third statement explains the first statement correctly. The reason for the Earth's rotational axis is being shift, revolutionary axis being is shift is you are running in the track. If I add weight to this place, you might run in the outer circle, right? If I add weight to this side, you might run in the inner circle, right? The balance will go off. Likewise, earlier, the polar ice caps on both north and southern hemisphere was there. It started to melt. By the melting of polar ice caps, the mass of the Earth, it is being shifted from the polar region to the equator region. That's why the rotational axis is being shifted. So here the answer is 2 and 3 are correct, but only the third statement explains the first statement. That is the answer. Only third statement explains the first statement better. With reference to direct air capture, consider the following statements. Direct air capture means from the air around us, we are capturing carbon dioxide from the air around us. This is done for carbon sequestration. It is useful in industries such as plastic and food processing. In aviation, carbon dioxide captured using DAC can be combined with hydrogen to make a synthetic fuel. Which of the above statements are correct? Direct air capture is a new technology where carbon dioxide, later carbon oxygen will be separated by various other methods. Here, direct air capture for carbon separation, and it is useful for plastic and food processing industry. That's also correct. Then it can be used to create synthetic fuel by combining it with hydrogen. All the statements are correct here. This is also a current affair part. That's it. Have you seen a single question from space technology? Single question from defense technology? Single question from biotechnology? Yes, it was there. Monoclonal antibody, biotechnology. Space technology, yes, Earth's axis is being changed. Space technology or astronomy, we can say, right? Link to the major topics will definitely be there. Information technology, yes, quantum computing, it was there, right? Chemistry, yes, electrochemistry, battery, based on the different types of battery, two questions were there, right? Likewise, you cannot decide the trend by solving a single question paper or 2-3 years question paper. It will definitely change. Generally, the aspirants call UPSC as unpredictable service. Unpredictable. Why unpredictable? You cannot expect. See, for example, in the last year, current affair questions are more. What you will think? On next year, it might be less, but it might not be the case. They might ask more questions this time also, right? You should be ready for anything because you have only one option. In your degree, if you fail this sem, you can clear by next sem, right? At least by the end of your degree, you can clear. But it is not the case here. You need to wait for one whole year. That is the case. That's why it feels little difficult. That's it. Okay. What do you think by seeing the questions? Hmm? Without even studying for UPSC examination, based on your educational qualification, at least you have passed your plus 2, right? You should be in a position to answer at least 2-3 questions here. That is the basic requirement. If not, you should go to the basics once again. What is virus? What is cell? What is antibody? What is battery? Which kind of energy it converts to which form? In a battery, remote cell, battery is there, right? Which form of energy it converts to which form? You have a battery in your remote. Okay, TV remote. It converts which energy to which energy? No, no. I'm asking. It produces electricity, right? DC itself. No AC current is there in the battery cell. DC itself, it's there. It is producing electricity. The battery. How it is producing the electricity? By the chemical reaction, right? Chemical energy to electrical energy. Do you know the dynamo? Dynamo converts. Do you know the dynamo? Dynamo. Earlier, In the bicycle, there used to be a device which we can engage, disengage with the rear tire. If you pedal faster, light glows brighter. Dynamo, mechanical energy to electrical energy. Then wind turbine, windmill, wind energy to mechanical, later electrical, right? Okay. How many Newton's laws are there? First law, second law, third law. First law of inertia. A paper, above the paper, object is there. If I drag the paper faster, the object will be here itself. Inertia of rest. I'm moving in the car. If the car brakes suddenly, I move forward. Inertia of motion. Newton's second law, force is equals to mass into acceleration. Newton's third law, every action there is equal and opposite reaction. Likewise, we have three Kepler's laws of planetary motion. Kepler's laws of planetary motion, we have three laws. Earlier, human thought we are the only living intelligent beings present in this planet, or maybe this universe. They thought Earth is in the center and Sun is revolving around us. The theory is called as geocentric theory. Earth at the center, Sun revolving around us. Geocentric theory proposed by Ptolemy. Is this true? No. Later we got to know, no, Sun is at the center and all the planets are revolving around the Sun. Even Earth is revolving around the Sun. This is heliocentric theory. Helio means Sun, geo means Earth. This is geocentric theory. This is heliocentric theory. Heliocentric theory proposed by Copernicus. Copernicus. Sun rises in the dash direction, sets in dash direction. Sun rises in the east, sets in the west. Earth rotates from which direction to which direction? East to west or west to east? From west to east. Earth rotates from west to east. That's why we see sunrise in the east. Sun never rises, never sets. Due to the rotation of Earth, we feel like sun is rising and setting, right? Due to the rotation of Earth. In the normal, simple two-dimensional diagrams you might have seen, sun bigger size. Then we have Mercury, Venus, Earth, Mars, asteroid belt. Then we have Jupiter. Then we have Saturn. Then we have Uranus. Then we have Neptune. The mass of the outer four planets is very huge. For example, let's say total mass of all the planets is 100%. Then 99% of the mass is with the outer four planets. 100 kg means 99 kg outer four planets. The inner four planets only 1 kg. Usually the diagram which we generally see, which we generally have seen in our books, it was not into the scale. Ratio was not proper. Just imagine how small Earth will be in front of Jupiter. Very minute, small dot ball kind of thing. Okay. Here, Does all the planets revolve around the sun in the same plane? No. Same plane means all these planets are not in the same plane. Then how they will revolve around the sun? See, sun is here. One planet is revolving like this. Other planet is revolving like this. Other planet is revolving like this. Three-dimensional with some inclination, they are revolving. But for simple basic understanding, we have considered they are revolving simply like this. But it is not the original case. Okay. Kepler's first law of orbits, called as law of orbits, Kepler's first law. In our school days, they taught us how to draw different shapes. For you to draw a square, for you to draw an ellipse, how you draw the ellipse? Freehand diagram. No. Ellipse. Two foci point, one half circle, then freehand. You connect. This is the ellipse, right? Ellipse. Ellipse will be having two foci point, two center points. Ellipse. Okay. Planets revolve around the sun in elliptical orbit. That's it. The first law. First law. Planets revolve elliptical orbit. Elliptical orbit. Law of orbit says around the sun, planets revolve in the elliptical orbit. That's it. Planets revolve around the sun in the elliptical orbit. First law. Here is the campfire. You are walking in this track, elliptical track. When you come near to the fire, you feel the warmth. You feel the warmth, right? If you go away from the fire, you might not feel the warmth, you might feel cold due to the outer weather, right? Likewise, here also, if the planet is near to the sun, the temperature will be high. If the planet is far from the sun, the temperature will be less. Seasons are formed due to Kepler's first law. Seasons. Different seasons are formed due to first law. Different seasons are formed due to Kepler's first law. First law called as law of orbits. Law of orbits. Kepler's first law. Law of orbits. Kepler's first law. See here. Sun is at the center. Planets are revolving around it in elliptical orbit. All the planets are revolving around the sun in elliptical orbit. Elliptical orbit. If the planet is very near to the sun, if the planet is very far to the sun, the nearest point, the shortest distance is called as the shortest distance between sun and the planet, sun and the earth. The shortest distance is called as perihelion. Perihelion, the shortest distance. The longest distance between sun and the planet called as aphelion. Aphelion. Why helio? Because sun is at the center. Perihelion, aphelion. The shortest, longest distances. If Earth is at the center, Earth, and any object revolves around it in elliptical orbit, what revolves around the Earth? Moon and other artificial satellites, right? For example, let's say moon. If moon is very near to the Earth, this shortest distance is called as perigee. G because geo, Earth is at the center. Then the longest distance is called as apogee. Perigee, apogee comes when Earth is at the center. Perihelion, aphelion comes when Sun is at the center. The basic things. Perihelion, shortest distance between the planet and the Sun. Aphelion, longest distance between the planet and the Sun. Kepler's first law, called as law of orbits. Say, let's say you travel to Bangalore from your native just for studies. Assume at your native you had a very close friend which you used to meet him regularly. When you are very close, staying in the neighborhood, the amount of friendship bonding would be higher, right? When you are far away from him, the bonding, friendship, the frequency of meeting, the frequency of calling will obviously reduce. Likewise, gravitational force we have discussed, right? Newton's law of universal gravitation. Gravitational force directly proportional to product of the masses, inversely proportional to square of the distance. Capital letter G means gravitational constant. F is equals to G into m1 m2 divided by r square, right? Here mass of the object matters. If mass is more, gravitational pull will be more. If distance is more, gravitational pull will be less. Distance matters. If distance is less, gravitational pull will be what? More. If distance is more, gravitational pull will be less. Just imagine, we have launched so many satellites to the space, right? So many satellites. We do you know about the International Space Station? International Space Station. India is planning to have its own space station by 2035, 2030, 2035. Own space station. Space station means a permanent object capsule revolving around the Earth, inside which we can go stay for some time, make some observation, calculation, research. Right now, the world, Earth, have two space stations. One is International Space Station with the collaboration of many countries, and the other is China's space station. China is having its own space station. Okay. The International Space Station is at a distance of around 405, 408 kilometers from the mean sea level. From the mean sea level, it's at a height of 458 kilometers, around 400 kilometers, let's say. The orbit will be a little changing based on some experiments they used to do. And the communication satellite. What? Communication satellite. Earth is rotating at what speed? Rotation means in its same axis. Revolution means around the sun. Around the sun, it takes 365 days. 0.25, leave it. 365 days it takes. In its own axis, it takes 24 hours, 1 day. It takes 1 day to make a single rotation, right? Earth is rotating like this. If object here is also here, parallel to the face of the earth, let's say this point, if it is moving at the same pace, they can communicate, right? I'm rotating like this. You are sitting there itself. Can we communicate face to face? No. If you are also moving in that path, we can communicate, right? I'm standing here. I'm rotating here. You are standing there, some 10 meters away from me. The radius of the circle which you are moving around me will be 10 meters. The time I take to make one revolution, the time which you take to make one revolution will be the same if you stay just in front of me. But speed of you will be more or less. See, simply. International Space Station is at a distance of 405, 408 kilometers, right? International Space Station will take 90 minutes to make one revolution. How much time? 90 minutes. In a day, it will make 16 revolution around the Earth. 16 times it will rotate around the Earth in 1 day. And the communication satellites, they are placed at a distance of 35,786 kilometers. In UPS examination, in a statement, they have asked 35,786 kilometer distance. Why that much far? If the object comes closer, the gravitational pull will be more. If the distance is less, gravitational pull will be more. If the gravitational pull is more, orbital velocity will be high. It will move at a faster rate. Gravitational force is more, right? If it moves away from the object, gravitational pull is less. It will move at a slower pace, slower. If it is near, the speed will be more. If it is far, the speed will be less. Why speed is more when it is near? Due to the gravitational pull. Why it is slow when it is far? Gravitational pull is less. That's it. If the object is near to the earth or sun or anything, the speed will be more. If it is away, the speed will be less. Simply. The first planet revolving around the sun is Mercury, right? It takes around 88 days to make one revolution. How much? 88 days, one revolution. How much time Earth takes? 365 days. Slower, right? It is faster, right? Likewise, the nearby object International Space Station takes only 90 minutes. The communication satellite takes 24 hours to make one revolution, See, Kepler's second law, Kepler's second law. Law of equal areas. Law of equal areas, Kepler's second law. First law says, what does it state? Planets revolve around the sun in elliptical orbit, right? Planets revolve around the sun in elliptical orbit. Elliptical orbit, it states, right? Okay. See, first law states planets revolve in elliptical orbit. Second law, law of equal areas. See, if the planet is near to the sun, gravitational pull is more or less? More. If the planet is far from the sun, gravitational pull is less. If the gravitational pull is more, orbital velocity will be more or less? More. Speed is ಜಾಸ್ತಿ ಇರುತ್ತಲ್ವಾ? Speed is more, right? If the planet is near to the sun, for example, let's say in 1 month. In 1 month, it covered this much distance, longer distance. Okay. If the planet is far from the sun, orbital velocity will be less slow. It moves slower. If the distance is more, it will cover only this much distance in 1 month. In the same month, same duration, it covered only this much distance. Second law states the area swept by the object, the planet, the area swept by the object, the planet is same. Area 1 is equals to area 2. Here and here both the distance covered is different. Here the distance covered is more, here the distance covered is less, but the area swept is same. This is called as law of equal areas. The swept area is same in both the cases. Law of equal areas. The thing which we need to know is from the second law. From the second law which we need to know, if the planet is near to the sun, orbital velocity is more or less more. Likewise, if the planet is far from the sun, orbital velocity will be less. That's it. This is the thing which we need to know. If it is near to the sun, orbital velocity more. If it is far from the sun, orbital velocity less. That's it. Kepler's first law of orbits. In the elliptical orbit, planet revolve around the sun. Second law of equal areas. Law of equal areas. The area swept in both the cases is same. If the object is near to the sun, orbital velocity is more. If it is far from the sun, orbital velocity is less. That's what we need to know. Orbital velocity. Then the third law of periods. Law of periods. Third law. Kepler's third law. Law of periods. Time period. Avadhi. Law of periods. Third law states square of the time taken to make one revolution is directly proportional to cube of the mean distance. Square of the time taken to make one revolution directly proportional to cube of the mean distance. square of the time taken to make one revolution is equal to square of the time taken or time period for one revolution is directly proportional to cube of the mean distance. That means t square directly proportional to r cube. For the Mercury, the orbit is smaller, right? For the Mercury, the orbit is small. Orbit small. For Venus, comparatively bigger orbit. Earth, bigger orbit. Mars, still bigger orbit, right? The orbit of Mercury is small. How much time Mercury takes to make one revolution? 88 days. Orbit of Venus comparatively big. How much time does it take to make one revolution? 225 days. How much time Earth takes? 365 days, 687 days, etc. Jupiter takes 11.86 Earth years to make one revolution. 1 year in Jupiter is 11.86 Earth years. Okay. If the orbit is smaller, the time taken is also smaller. If the orbit is bigger, the time taken is also higher. That's it. That is third law. Square of the time taken for one revolution directly proportional to cube of the mean distance. Cube of the mean distance. That's it. This is Kepler's law. If the orbit is smaller, the time taken is less. Shorter the orbit, shorter the time taken for one revolution. That's it. If larger is the orbit, more is the time taken for one revolution. Shorter the orbit, shorter is the time taken for one revolution. Kepler's third law. Shorter the orbit of the planet, shorter is the time taken to complete one revolution. Third law. Where is the headquarters of ISRO? Huh? Bangalore. Yes. Indian Space Research Organization, ISRO. Under ISRO, recently, two new organizations have started, one PSU and on other organization. Have you heard the names of NSIL and InSpace? InSpace and New Space India Limited, NSIL. We'll discuss very important organizations. ISRO started with a goal or reason. What is the reason? To send satellites to space. Simple, right? ISRO, Indian Space Research Organization. When India got independence, right. Once we got our independence, we started to figure out our regional demographic political issues. India was a poor country back then because each and everything, the resources present in us were looted. Later, we thought we need to grow economically, politically, etc., etc. So, if a poor person wants to grow up in life, what he should do? Earn more money, gain more knowledge, get a good job. That's it, right? Likewise, India thought, let's make some research advancement in the field of science and technology and in the field of education, etc. The first artificial satellite, world's first artificial satellite. Do you know the name? World's first satellite. Sputnik by the Soviet Russia. Now the Russia, Soviet Russia separated to Russia, Ukraine, etc., etc. Earlier it was USSR. Sputnik satellite launched. Sputnik. Later Indians thought, okay, 1958 they have launched the Sputnik satellite. You might have heard the name Sputnik recently, right? During the time of Corona. Have you heard the name Sputnik? Russia announced we have successfully developed world's first vaccine against corona and they have named it Sputnik V. Sputnik the vaccine. Actually, Russia was the first country, USSR the first country to launch the first satellite to space. That's why they wanted to have that name, Sputnik, for the corona vaccine also. But they haven't developed the vaccine to its fullest strength. But they just announced that we have already developed the vaccine, Sputnik V. Once USSR launched its first artificial satellite, Indians thought, okay, let us also start our own space agency. Let us have our own space organization. So, under the leadership of Dr. Vikrama Sarabhai, under the leadership of, we can write it later. It's just a foundation. We'll discuss these things again. Before moving on to the discussion about the different type of orbits, let's discuss this basic thing. We'll come back later. Under the leadership of Dr. Vikrama Sarabhai, who was our prime minister back then during 1950s, 60s, Jawaharlal Nehru was there. Under his visionary, under the leadership of Dr. Vikrama Sarabhai, we have started our first space agency named INCOSPAR. In 1962, it was INCOSPAR, Indian National Committee for Space Research. Indian National Committee for Space Research. It was incubated, helped by Dr. Homi Jahangir Baba, Department of Atomic Energy. He helped. Later, in 1969, the name changed from INCOSPAR to ISRO, the present organization which we have. If they ask when was ISRO formed, then you should say in 1969. Earlier organization, you know, need to worry. The INCOSPAR. August 15th, on the eve of Independence Day, the name changed from INCOSPAR to ISRO, Indian Space Research Organization. The headquarters is in our Bangalore, ISRO. We have started our space agency, like a travel agency. Travel agency, what it will do, it will transport the passenger goods to the suitable destination, right? It will be having a route, it will be having a vehicle, it will be having a payload. Route, passenger, vehicle. Likewise, here also, we need to transport different satellites to the space, the two different locations, different orbits, different altitudes, right? Then what we need? Vehicle. The space vehicles are called as rockets. Rocket, space shuttle, rockets. Can you name any rocket which we have, which ISRO have? Aditya L1 is a mission. It's a satellite. To the Lagrangian point 1 L1 is, ISRO made its first attempt to observe or research about a sun's atmosphere. That is Aditya mission. It's a mission. It's not a rocket. Rocket means the vehicle. Which vehicles do we have? That's a means it's not official. No? Generally, we do call it as Bahubali because it is having the ability to carry so much payload. That's it. We do have Polar Satellite Launch Vehicle, PSLV. Geosynchronous satellite launch GSLV. Geosynchronous satellite launch vehicle 3 GSLV Mark 3 or LVM3. Then we have small satellite launch vehicle. Earlier, when in 1962, Incospar started. In 1969, ISRO started. Under the leadership of Vikrama Sarabhai, they thought, let us build a satellite first. India is in good relationship with Russia, right? In US also, okay, good relationship it is having. With the help of Russia, with their rocket, the launch vehicle, Intercosmos 1, we have launched our first satellite. India's first artificial satellite, Aryabhata. India's first artificial satellite. We have launched the satellite. Successful launch. Then later we thought, okay, we have launched the satellite successfully. We got to know how to launch the satellite. Later we thought, let us have our own vehicle, launch vehicle. Later they have developed a launch vehicle called SLV, satellite launch vehicle. The first attempt it failed. In the second attempt, in the 1975, we have launched our first satellite to the space. In 1980, with our own rocket named SLV-3, we have launched the next satellite. Later, SLV-3, satellite launch vehicle 3, updated to augmented satellite launch vehicle, then updated to polar satellite launch vehicle. Then we have GSLV Mark 3, SSLV, etc. We are planning to develop an NGLV, new generation launch vehicle, and we are planning to develop a reusable launch vehicle. Technology demonstrator is there. It is in the experimental phase. One fine day we will also have the technology. Right now, currently, does any space organization around the world have reusable launch vehicle? A reusable launch vehicle means the same rocket which can be used once more. Is there any technology available right now? You haven't seen the SpaceX landing video. Do you know about SpaceX? SpaceX company. No, you haven't heard about SpaceX. You have. Good. Elon Musk. Starlink will discuss later when we started to discuss about that orbits. You know about Elon Musk, right? Tesla. Same. Here's one more important company, SpaceX, a private space agency based in America. Private space company based in America. He has his own, means the company's own reusable launch vehicle. What does a reusable launch vehicle mean? See, generally the rocket, it will be of this shape, right? Pointy at the end, bigger at the bottom. Gas is burning and it moves up. Newton's third law. In the top, payload will be there. Payload means satellite, which we need to place into the orbit. Then there will be at least 3-4 stages of different engine. Engine stage 1, engine stage 2, engine stage 3, stage 4. Okay. What happens during the launch? Booster jet, then first stage of the engine will start to burn. Once it reaches some height, the first part will detach and it will fall back to the earth, into the ocean generally. Okay. Then the second part will start to burn. After the completion, it will also detach and fall. Then the third part, then the fourth part. The last part will help in placing the satellite into the suitable orbit. Once the rocket placed the satellite into the suitable orbit, is there any part of the rocket left? No. Every part is detached already and fell back into the earth, right? That's why this rocket cannot be used again. For each and every launch, right now, we are developing a new rocket. For each trip to your home, you are having a new scooty. Just imagine that kind of thing. If you have a reusable launch vehicle, it will be less costly, right? Cheaper, right? That's why we are planning to have the new reusable launch, but it is still in the testing phase. Only SpaceX have that successful technology of reusable launch vehicle, a reusable launch vehicle. Okay. Then later, we have started to launch various kinds of satellites to the space, and before the day we have launched our ISRO, August 15, 1969. In the month of July, in the month of July, US landed their men on the moon. Before we starting our space agency, Neil Armstrong, Edwin Buzz Aldrin landed on the moon. Right? See, just imagine. Here in the case of your UPSC preparation also, you have started just now. You're in the initial phase. There are so many aspirants who have already prepared for many years with so much experience. They are also in the race. Many cleared aspirants who have got other services, they are also in the race. You need to compete with them, right? India also did the same. It competed with all those big space agencies. You might have heard about the record launch which India made in a single attempt. In a single attempt, India launched 104 satellites into the space. Not 1, 2, 3, 104 satellites. Successful launch. In that launch, majority of the satellites were from America. Majority of the satellites. That is success, right? Because we are economical, we are efficient. That's why our PSLV is so famous. Many foreign countries launch their small satellites with us, with ISRO. Okay. Then India thought recently, let us send human to space. Already in 1960s only, Russia sent Yuri Gagarin to space. Russia sent Valentina Tereshkova to space. Americans sent humans to the moon, right? Till date, till date, only two Indian citizens went into the space. See, our Kalpana Chawla, Sunita Lynn Williams, they're Indian origin, but they're US nationals. Indian Indians who went to space are one is Rakesh Sharma, who went to space in 1984. Then recently, Shubhanshu Shukla went into space and came back safely. Right, these two. Let us see the different orbits where we can place our satellites into around Earth. From 200 kilometer to how much? 200 kilometer to 2000 kilometer. 200 to 2000 kilometer. This orbit, 200 to 2000 range. This is called as low Earth orbit. Low Earth orbit. Low Earth orbit. 200 to 2000 kilometer. Based on Kepler's second law, if the object is near to the Earth, gravitational pull is more. Orbital velocity is more. right? If it is near to the Earth, shorter the orbit, speed is more, time taken is less, speed is orbital velocity is more, right? 200 kilometer to 2000 kilometer low Earth orbit. In the low Earth orbit, what kind of satellites we can place means, what kind of satellites which we can place means in the low Earth orbit. One, we have International Space Station and we have Chinese Space Station. We can have space station just for observation purpose to make studies in microgravity. Okay, International Space Station we have. Then we have space telescope. Space telescope. For example, Hubble Space Telescope, etc. Have you ever viewed the planet Venus, the planet Saturn with the help of a telescope in your school days? Have you seen the telescope personally, physically? In the picture you might have seen, right? Usually the telescope used to be placed in the higher floor above, right? So that open sky is seen. If you are observing any celestial bodies from the earth, if I am observing that person from here, I might not observe the minute details, right? If I go and stand in front of him, it would be better. If I just move little near, that would be better. Likewise, instead of observing from the surface of the earth, if I observe from the low earth orbit, it would be better. To observe the celestial bodies, we have space telescopes in the low earth orbit. Space telescope to observe other celestial bodies, other planets, other stars, pulsars, quasars, etc. Asteroid, meteor, etc. That's why we have space telescopes. Then, can communication satellites be placed in the low Earth orbit? Is it possible? Communication satellites in the low Earth orbit. Communication satellite means, for example, the satellite which gives us internet connection, the satellite which helps in mobile phone communication, the satellite which helps in DTH connection, TV. See, this object is moving in a circular path. In its own axis, it is rotating. Okay. Earth is also rotating like this, right? Earth is also rotating like this. If I place the satellite here near to the Earth, what this satellite will do? It will move very faster. 90 minutes one round. Which one? International Space Station. If it moves this fast, can this person standing at this point communicate with this satellite? No. Continuous communication is not possible. One continuous communication is possible at some point. At some point, the object is here. It is also moving. It is also moving in the same pace, same speed. This takes 24 hours to make one rotation. This takes 24 hours to make one revolution. Then they can communicate, right? The distance in which the object, the satellite can be placed where the revolution speed is 24 hours, that is 35,786 kilometer. 35,786 kilometer. Just imagine all the communication satellites which we have right now are at a distance of how much? 35,786 kilometer from the mean sea level. The normal satellites which we have near our Earth are low Earth orbit satellite. Low Earth orbit satellites are Earth observation satellite. Earth observation. By moving fast around the Earth, we can just observe, right? Observation satellites are there in the low Earth orbit. Space telescope, it's there in the low Earth orbit. Then International Space Station, it's there in the low Earth orbit. Then remote sensing satellite, kind of observation satellite only. These kind of satellites are there in the low Earth orbit. Which kind of satellites cannot be there in the low Earth orbit? Which can't be there? DTH of communication, then weather observation, forecasting satellites cannot be here. For you to observe weather in this location, satellite should be here itself, right? It should not be moving faster. So those kind of satellites cannot be there in the low Earth orbit. It cannot be there in the low Earth orbit. Which kind of satellites can be there? Earth observation satellites can be there. International Space Station can be there. Space telescopes can be there. Remote sensing satellites can be there in the low Earth orbit. For a problem, there will be a solution, right? Now the problem is communication satellites are far away from Earth. If it is far away from Earth, it takes more time to communication, right? It takes more time. More time means, just imagine how much time sunlight takes to reach Earth. How much time sunlight takes to reach Earth? First option 1 hour. First option 1 hour. Second option 1 second. Next option 8 minutes. Option none of the above. 1 second. The distance between Sun and Earth, it's elliptical, right? We cannot say single distance. The average distance, we can say average distance. The distance is called as astronomical unit. 1 astronomical unit. Before discussing this, let's discuss these basics. From the center of the Sun to the center of the Earth, the average mean distance 149.9998 into 10 power 6 kilometer. That we can simply say 150 into 10 power 6 kilometer. That is 150. How much? Million kilometer. This is called as 1 astronomical unit. 1 AU, astronomical unit. Average distance between Sun and Earth, 150 million kilometer. 150 million kilometer, the average distance. Does light require medium to travel? Does light require medium to travel? Yes or no? Does sound require medium? Can sound travel in vacuum? Can sound travel in vacuum? No, it cannot. How sound travels? By the vibration of particles. When you speak, there is vibration, right? By the vibration of particles, sound travels. It requires medium. When compared to air, sound travels faster in water. When compared to water, it travels faster in solid objects. Sound. Okay. Light requires no medium. Light travels in all the transparent objects or transparent medium. Light can travel in vacuum. Light can travel in air, water, glass, plastic, diamond, etc. Right? The speed of light will change when it travels from one medium to another, right? When compared to vacuum, the speed of light in air will be little less slow. Glass little slower, diamond little slower, right? Speed of light in vacuum is speed of light in vacuum. How much? Speed of light in vacuum, that is 3 lakh kilometer per second. Just imagine 3 lakh kilometer per second. Speed of light in vacuum. In your bike, you might travel in 100, 150, 160, 180 kilometer per hour. Here, 3 lakh kilometer per second. Speed of light in vacuum. That we can also write as 3 into 10 power 8 meter per second, right? Lakh means 5 zeros, kilo means 3 zeros, 5 plus 3, 8 zeros. 3 into 10 power 8 meter per second. Speed of light in vacuum. Now, speed is equals to distance traveled by time taken. Now tell me the time. Time is equals to speed distance. Ulta. Distance by speed. Distance 150 into 10 power 6 million kilometer. Speed 3 into 10 power 5 kilometer per second. If you solve, how much you get? 500 seconds. This much time light takes to reach Earth from the sun. 500 seconds means how much? 1 minute to 60 seconds. 8 minutes. 8 6 are 48. 20 seconds. Light takes 8 minutes 20 seconds to reach Earth from the sun. The light which we are getting right now started 8 minutes ago from the sun to reach us. It takes 8 minutes 20 seconds. One astronomical unit means very important. One astronomical unit means approximately 150 million kilometer. 150 million kilometers, the distance. 150 million kilometer. To measure a distance, we use millimeter, centimeter, meter, kilometer, right? SI unit, SI unit of distance, meter, meter, SI unit. Okay. To measure the longer distances, we use 1000 kilometer, 1 lakh kilometer, 10 lakh kilometer, right? If the distance is still more, for example, see, distance between sun and earth is 150 million kilometer, right? Sun is actually very near to us when compared to other stars in the universe. When compared to other stars, it's very near, right? To measure the longer distances, we use the term light year. Have you heard the term light year? Light year? Light year is a term used to measure the distance between two celestial bodies, distance between two stars, distance between earth and a star, distance between earth and some object. Light year. One light year means speed of light in vacuum is how much? Speed of light in vacuum, how much? 3 into 10 power 8 meter per second. 3 lakh kilometer per second, right? Just imagine. The distance covered by light in vacuum in 1 year. In 1 second, light travels 3 lakh kilometer. 1 second. In 1 year, the distance it travels, that is 1 light year, the distance, which we can literally cannot imagine the distance, right? the distance light travels in 1 year in vacuum. That distance is called as 1 light year. 1 light year. 1 light year is equals to distance light travels in 1 year in vacuum. That is 1 light year. 1 light year is equals to 9.46 trillion kilometer. Trillion kilometers. 1 light year means 9.46 trillion kilometers. 1 light year. To measure the distance more than light year, there are so many objects which are lakhs of light years away from us, crores of light years away from us. To measure that, we use parsec. 1 parsec is equals to 3.26 light year. 3.26 light year. 1 parsec is equals to 3.26 light year. Parsec means parsec. These are the measuring units which we use when we measure the distance between two celestial bodies. Distance between two celestial bodies. What is the shape? What is the name of our galaxy? Milky Way galaxy, right? The shape of our galaxy is spiral galaxy. Our galaxy. Galaxies are generally in the shape of ellipse, spiral, and irregular shaped. Okay, elliptical, spiral, and irregular. We are, our solar system is in the Orion arm. There are so many arms, right, in the spiral shape. In the Orion arm, the inner edge, the solar system is there. Millions of stars are there in this galaxy. Millions of stars. Among them, Sun is a star. Around that, we, 8 planets are revolving. In that planet, we are living. Just imagine how meager, small, minute we are to this universe. Right? The distance from this center of the galaxy to our solar system is around 40,000 light years. That much huge the size of a galaxy is. Like this, millions of galaxies are there in our universe. Right? Take a break. We'll discuss about different types of orbit and we'll cover different types of orbit today. Low Earth orbit, polar orbit, sun synchronous orbit, geosynchronous orbit, geostationary orbit, geotransfer orbit, geosynchronous equatorial orbit. Simple. This many orbits are there. We'll cover. Actually, if you understand, it's very easy. If you try to remember, if you try to by heart, then that will be little difficult. We'll discuss. Take a break for 5 minutes. Okay. Low Earth orbit from what distance to what distance? 200 kilometer to 2000 kilometer from mean sea level. Okay. From 200 kilometer to 2000 kilometer, which kind of satellites we can place in the low Earth orbit? The International Space Station is there. The remote sensing satellites are there. Earth observation satellites are there. Space telescopes are there, right? These sort of satellites can be placed. Which cannot be placed, that is very important. We cannot place communication satellites in the low Earth orbit. We cannot place weather observation, DTH, this kind of satellites in the low Earth orbit. If there is a drawback, if there is some issue, there will be a solution also. Do you know about the Starlink project by SpaceX company and Project Kuiper by Amazon company? Have you heard about these projects? What do you know about Starlink project? You have heard about the project at least. The main agenda of the Starlink project is to get high-speed internet connection, basic high-speed internet connection. How? Actually, communication satellites are generally placed in the longer orbit, 35,786 kilometer, right? Here, Elon Musk and his team they thought in the low Earth orbit, we cannot place a communication satellite because in the low Earth orbit, the satellites will move faster. Orbital velocity is more. It will not be staying at a single place. Just imagine. Our Bangalore PES University is there, right? They have launched their own satellite. They have developed a satellite. Likewise, there are many institutions, universities who have developed their own satellite, and with the help of ISRO, they have launched their satellite to the low Earth orbit, usually to the low Earth orbit. Let's say we have developed our institution's own satellite. Imagine communication satellite for our own private communication. That satellite should be launched to a distance of 35,786 kilometers. Then only when the earth moves, the institute will also move, right? This is also moving 24 hours a day. 24 hours per day. It takes 24 hours for one revolution, right? One rotation, 24 hours. That satellite will also be moving at the same speed. If we see 35,786 kilometers above, that satellite is there. Our institution's communication satellite. The speed of that satellite is equal to the speed of Earth's rotation. 24 hours, one rotation. 24 hours, one revolution. We can communicate. But if it moves faster, we cannot communicate, right? If it moves faster, we cannot communicate. That's why what SpaceX company thought, let's place thousands of satellite, not one, two, thousand, thousands of satellites in the low Earth orbit. Thousands of satellites in the low Earth orbit. It looks like a string of light moving in the sky. Usually satellites will not be having any light, no requirement is there. But for advertisement purpose, what they have made, the SpaceX company, each one will be having a light. So that few years back, when they started to test 1, 2, 3 years back, it looked like serial set light moving in the sky. It appeared like some strange object with so many light dots moving in the sky. It was there in the newspaper. It was seen in Karnataka also, in Chitradurga, various other regions. It was seen in the sky. This is Starlink project. They are planning to have thousands of satellites. See, like this, it was seen in the sky from the Earth. A series of star kind of objects in the sky. Why the name Starlink? Each and every satellite is linked to the other satellite in that group. Here, you are standing. This is Earth. Around Earth, we have thousands of satellites in the low Earth orbit. If me standing here I am communicating with this satellite. After some time, it will move faster, right? Each and every satellite will be moving at a higher speed because the distance is low. Gravitational force is more. Orbital velocity is more. So if I communicate with this satellite, it will communicate with each other satellites. So by the time I get the response, it will be from probably this satellite. Then I will respond probably to this satellite. I will again get the response back probably from this satellite. But all these satellites are interconnected, right? That's why I can communicate. Simply just imagine. Your father is very strict. He will not allow you to go and play with your friends in the evening after the class because he wants you to study every day evening. But you are the only person who has a new bat, cricket bat. Each and every friends, neighbors wants you to come and play. If one person directly comes and stands in front of your gate and asks your father's permission, he will scold, beat him, and scare him away. What your friends thought? Let us make a circle. Let us move continuously around his home. 10 of your friends moving in their cycle around your home continuously. One person asked you through the window, will you come? Let's go out and play. And he moved away. Then you will respond, okay, wait for 5 minutes. Let him go to the washroom, I'll come. Right? They communicate with each other. The communication is complete, right? Then one other person will say, okay, that's fine. Come as early as possible. This kind of communication happens when more number of satellites are in the low Earth orbit. The main goal is to get high-speed internet connection. If the satellite is there in 35,786 kilometer distance, it takes more time. That's why they have planned, let's place more number of satellites. But there are some demerits. What is the demerit? Traffic jam will happen in the space if more number of satellites are placed. That's so, right? Space debris will increase. That is also there. 100% in this year or next year, a question will come regarding the space debris mitigation. How to control the space debris? China, a year back, successfully tested a program where it created a web-like structure, web-like structure, and it easily captured many space debris from different orbits. In future, what will happen? There will be so many space debris in the space, right? Small nut, bolt, not functional satellites. If I want to place my satellite to that place, I need that place to be clean. What I will do, I will give money to China. Please clean this place. That will be a booming, economical, profitable industry in the future. Space debris mitigation. This is the problem. Once Starlink started by SpaceX, Amazon also thought, let us also do the same thing, placing more number of satellites in the low Earth orbit to get high-speed internet connection. Amazon company's project name is Project Kuiper. Have you heard about Kuiper belt? Have you heard about asteroid belt? Asteroid belt is between Mars and Jupiter. Between the Mars and Jupiter, we have asteroid belt, right? Likewise, around our solar system, after the Neptune, we have Kuiper belt. Same like asteroid belt, we have Kuiper belt. The name taken from there, Project Kuiper. Asteroids are small rocky objects, right? Likewise, small satellites are placed in the low Earth orbit. Project Kuiper. Amazon in the first phase launched 10,000 satellites. How much? 10,000. They are planning to launch thousands of satellites into the low Earth orbit. If SpaceX do this job, Amazon company do this job, even ISRO can do, even NASA can do. If each and every person starts to do the same job, then what will happen? Traffic jam in the space. That is the issue. In the low Earth orbit, what kind of satellites can be placed? Earth observation, remote sensing, space station, both China's and international, then space telescope. Communication satellites cannot be placed, but there is a special idea by these two big tech giants. They have a special idea. The idea is to place more number of satellites, very high number of satellites to get high speed internet connection. That is it. Starlink, the project Starlink by SpaceX will be in which orbit? If the ask means, it will be in low Earth orbit. That's it. Low Earth orbit. Okay, good. Next, we have medium Earth orbit. Not so important. Medium Earth orbit we have. Low Earth orbit not suitable for communication, weather observation, and forecasting satellites, because they don't spend very long time over a particular place. Orbital velocity is more. That is the reason. Then we have medium Earth orbit, 2000 kilometer to 35,786 kilometer. Medium Earth orbit. Medium Earth orbit, 2000 to 35,786 kilometer. Medium Earth orbit. Here, when compared to low Earth orbit, a less number of satellites are placed. Less number of satellites in the medium Earth orbit. In the medium Earth orbit, generally global and regional positioning. Satellites are placed. That means satellite which helps in navigation, global navigation or regional navigation. Navigation satellites are placed. Navigation satellites. We do use GPS for navigation, right? GPS full form? Global Positioning System. GPS owned by, who is the owner? America. Yes. We are getting the service from them. We are paying them for their service. Okay. GPS, Global Positioning System, very important. Listen. Global Positioning System, GPS, US, global navigation system. Okay. Then we have GLONASS, Global Navigation Satellite System. Global Navigation Satellite System. Russia's navigation system, GLONASS. Then we have Galileo, European Union. QZSS, Quasi Zenith Satellite System, Quasi Zenith Satellite System. Japan's navigation system, QZSS, Quasi Zenith Satellite System. BEIDOU, BEIDOU, China's navigation system, China. Then we have our very own navigation system called NAVIC. Navigation with Indian constellation. NAVIC. Earlier it had the name IRNSS, Indian Regional Navigation Satellite System. Indian Regional Navigation Satellite System. It was renamed by Narendra Modi as NAVIC, Navigation with Indian Constellation. NAVIC. India's navigation system. What is the use of our own navigation system? Right now, each and every road, curve, traffic, etc. data is with America, right? If we have to fight, if we have to if what war starts between India and Pakistan, India and China, we need coordinates, right? We need data about enemy hideouts. We need data about how to travel to that place. We need direction that we get from America GPS. What if they need to give us the data? That will be an issue, right? Have you seen the recent movie named Paramanu? Pokhran or Paramanu? It was a movie, not very recent, few years back, 2, 3 years back. Have you seen the movie Mission Mangal? You have seen Puri, right? Geo transfer orbit. We'll discuss here in the first during the time of first nuclear test. Nuclear test. Generally, we do nuclear test where in India? In the desert, in the Pokhran range, Rajasthan. Missile test we do in the ocean. Odisha's east coast, Chandipur region. Earlier, we used to call it as Wheeler Island. Right now, it is being renamed as Dr. APJ Abdul Kalam Island. Each and every missile we test in the Wheeler Island. Earlier, right now, APJ Abdul Kalam Island. Okay. And the nuclear test was done in the Pokhran range, Rajasthan desert. There, regularly, America's satellite will monitor the landmass, the area of Earth. The observation satellite will be in the low Earth orbit, right? Observation satellite will be in the low Earth orbit. At one point of time, it comes here and it moves. It will not be staying here for longer time because orbital velocity is more. During the complete daytime, maybe from 3 to 4, 5 to 6, or 1 to 2, that time only it will be at that place. Other time it will be moving around the earth. Except that time, Indian scientists knew that data at what time every day American satellite passes through this place. At that time, it will be observing that region. That is a very critical region, right? Pokhran region. Each and every day they used to make a research. They used to make changes, and outside the laboratory they kept it clean. One fine day, by hiding from the eyes of American satellite, they have done the nuclear test. Likewise, here, Navik, the main reason is during the time of war, etc. If we have our own coordinates, if we have our own navigation system, that will be helpful. Right now, navigation system, Navik is functional, but it is not there for the common man's use. We are right now also using GPS for navigation, but Indian Army, Navy, Air Force, they are using Navik system, and Indian Coast Guard, Indian what fishermen, they are using a special system called Gagan. They are using this Navik system. From the Indian land boundary, we can monitor 1,500 kilometers away. From our boundary, we can monitor 1,500 kilometers. That would be more than enough, right? When there is a standoff between India or China, India and Pakistan. That is the main reason. Earlier, it was named IRNSS. 9 satellites were placed. 9. Among those 9, one it is not functional right now, and one during the time of launch only it failed. 7 functional satellites. Later, recently, last year, they have launched 2 more Navig series of satellites. Second generation communication navigation satellites they have placed. We'll discuss. It's a regional navigation system. Regional navigation system means only restricted to India and 1,500 kilometers from the border of India. Global navigation system means whole globe. So, when compared to the number of satellites GPS global position system is having for the region of India, the number of satellites Navik is having for the region of India is more. So they are telling in the future, when we get access to Navik system, new app will come where we will be using Navik in our mobile phone for navigation. The accuracy will be very high. But they're telling once we get to use, we will know Navik system. In the medium Earth orbit, these kind of satellites are placed. Which kind of satellite? Navigation satellite. Global positioning. Navigation satellites are placed in the medium Earth orbit. Medium Earth orbit. Then we have polar orbit. North Pole, South Pole. Polar orbit satellite. This is also just like the low Earth orbit, polar orbit, low Earth orbit only, polar orbit. It revolves from one pole to another, pole to pole. See, Earth is rotating from west to east, right? Earth is rotating from west to east. If the satellite is also moving above the equator, it can only observe the sides of the Earth, not the top and the bottom. If Earth is moving from west to east and the satellite moving from north to south or south to north, then it can observe 360 each and every bit of the Earth, right? Complete the Earth globe it can observe, right? Google Earth kind of feature. Google Earth, the 360-degree view of Earth can be seen with the help of polar orbit satellite. To observe the complete sphere, globe, Earth, polar satellite, polar orbit satellites are used. Polar orbit. The distance is same, around 200 to 2000 kilometer, low Earth orbit only, polar orbit. Main reason of this orbit or use of this orbit, we can observe each and every part of the Earth. We can get the aerial 360-degree view of the Earth. See, during the time of Diwali, usually every year they will give or they will circulate a photo. You might have seen NASA taken a picture from the space. See how India looks from the space, right? That 360 view, that aerial view picture can be taken with the help of these polar orbit satellites, polar orbit. Then we have geosynchronous orbit. Geosynchronous orbit satellite. Geosynchronous orbit. Distance, fixed distance 35,786 kilometer. You should know the value. 35,786 kilometer. In UPSC CSA examination 3, 4, 5 years back, they have asked a question about geosynchronous orbit, in which they have given a statement telling that the orbit is a distance of 35,786 kilometer, and the statement was correct. Yes, it is at a distance of 35,786 kilometer. If the satellite is near to the Earth, gravitational force is more. If the satellite is near to the Earth, orbital velocity is International Space Station, 90 minutes one rotation, orbital velocity more, right? If the satellite is far from the Earth, orbital velocity is slowless. It moves slowly. At a distance 35,786 kilometer, the satellite takes 24 hours to make one revolution. 24 hours to make one revolution. That means the satellite feels like it is stationary to the person observing from the Earth. If we all place a satellite from this institution just 35,786 kilometer above, what we feel like when we see? We cannot see. 35,786 kilometer distance, it will always be there itself. It is also moving. We are also moving. It appears to be stationary. If both are appears to be stationary, we can communicate, right? So communication satellites are placed in this orbit. Geosynchronous. Synchrony means what? In tandem, in rhythm, right? Both are moving at the same speed. Geosynchronous orbit. Communication satellite. Then weather observation and forecasting. These satellites are placed in the geosynchronous orbit. Geosynchronous orbit. Just imagine you are making a phone call to your friend. You are making a phone call. From your mobile phone, the signals, they will be transmitted to the nearby tower. Right? From the mobile tower, it will be transmitted to the satellite. From the satellite, it will be transmitted back to the nearby tower where your friend is being located. From there, it will be transmitted to your friend. Right? This satellite is at a distance of how much? 35,786 kilometers. You are getting a DTH connection to your home, right? DTH connection. Those kind of satellites are placed in geosynchronous equatorial orbit. Same distance, 35,786 kilometers. Geosynchronous equatorial orbit. Geosynchronous equatorial orbit. That means, see, Earth's equator. These kind of satellites are placed horizontally 35,786 kilometers above the equator. Just above the equator. Just above the equator, 35,786 kilometers above, these kind of satellites are placed. Why only above the equator? Because in the southern hemisphere, in the northern hemisphere, we have places to communicate with, right? A cricket match is going in Australia, where in the northern hemisphere, we get the data from there to here, right? Those kind of satellites are placed in where? Geosynchronous equatorial orbit. Your home's DTH antenna, it should be placed in particular angle, right? If the angle varies, you will not get the connection. However you try to adjust, it will not. It's very difficult. By taking the calibration mission, the technician will adjust. Why? Here, the satellite is 35,786 kilometers above the equator, right? You are here who placed your digital TV antenna like this, and here the transmitter, the antenna placed at some angle. From here to here, the signal goes. From here to here, you get the signal. The distance of this satellite is how much? 35,786 kilometers from the surface. It is just above the equator. Normal communication satellites, see, normal communication satellites, they are also at the same distance, but they can be in the inclined plane also. Normal communication satellites, but DTH satellite, it should be horizontally above the equatorial plane. Okay. Geosynchronous equatorial orbit. What kind of satellites are there here? DTH communication satellites are there in the geosynchronous equatorial orbit. Then we have sun synchronous orbit. Sun synchronous orbit. Orbit which is in synchrony with the sun. orbit in synchrony with the sun. Sun synchronous orbit. This is also a kind of low Earth orbit. Generally, the distance is 600 to 800 kilometers from the mean sea level. Right now, if you have any cousins, friends, relatives staying in US, Europe, Australia, etc., what is the first thing you ask when you call them? What is the time there right now? Whether it is morning, evening, night, right? For example, right now, some part of the earth is getting light from the sun. Other part, it is dark. As the light moves, actually earth rotates, sun will not move. As the earth rotate, it is there, here. Likewise, it moves, right? As the sunlight moves, this satellite will also move. This is a special kind of observational satellite placed in the sun synchronous orbit. It is there to observe the surface of the earth. Major purpose, defense. For example, the American satellite, which used to monitor the Indian Pokhran region during some 1 to 3 hours every day, right? That will be in the sun synchronous orbit. Wherever the sunlight falls, satellite will be there so that it can observe easily. Sunlight will be there, right? Satellite will be in synchrony with the sun. As the sun moves, satellite will also move. That's it. Sun synchronous orbit. Which kind of satellites will be there? Observation. Major field of use, defense. Observation satellites will be there in the sun synchronous orbit. Satellite will be in synchrony with the movement of sun. Satellite will be in synchrony with the movement of sun. Sun synchronous orbit. Then we have geo transfer orbit. Geo transfer orbit. Normally, the orbits which we have seen till now, they are nearly circular. But this orbit, the geo transfer orbit, it is very much elliptical orbit. Which one? Geo transfer orbit. Have you seen the movie Mission Mangal? In that movie, Vidya Balan tells or shares her thought, idea. Where? What she shares?
Idea of putting when the heat is there, and after will travel.
Still, by the when you are cooking the last chapati, you turn off the gas, right? Just by the heat of the tawa, it will be cooked. Likewise, we have Polar Satellite Launch Vehicle (PSLV). PSLV's payload capacity is 1,750 kgs only 1,750 kgs. It can take satellites to low Earth orbit. Major goal, low Earth orbit. Maximum it can go to geosynchronous orbit with less payload. PSLV. Just imagine PSLV is your Splendor. Normal, low capacity bike. Okay. What ISRO done? Milestone achievement. They have used the PSLV to place a orbiter satellite to the orbit of Mars. ISRO is the first country in the world, in their first attempt only, they have successfully placed orbiter into the orbit of Mars. Before we placing the orbiter to the orbit of Mars, I mean satellite to the orbit of Mars, NASA have already launched, placed lander, rover, helicopter to the surface of Mars. But why we are special means we were very much economical, very much economical. First thing, second thing, with a small carrying vehicle, small launch vehicle, we have launched the satellite. Next, very important thing, we are the only first country. In our first attempt only, we have successfully launched the satellite into the orbit of Mars. Mars orbiter mission, MOM. In 2013, the rocket was launched. In 2014, it reached the orbit of Mars. How means, see, from the surface of the earth, from the surface of the earth, the rocket was launched. It was launched from here to here, the power was used. Fuel power was used. Here, the engine was turned off. They have an idea. It was turned off. When you place an object into the orbit in the space, it will automatically move due to the gravity. Like moon is rotating around the earth, like earth is rotating around the sun. Likewise, only it will rotate in that orbit. This orbit is geotransfer orbit, elliptical orbit. Here, they have launched the satellite with the rocket to this place and turned off the engine. And they waited for some time. You might have seen in the movie, today is the time. If you don't utilize this time, we cannot do the launch in the next 2, 3, 4 years, right? They used to talk because if they don't launch the rocket at this place to the other orbit, this orbit is the orbit of Mars. Then they should wait for this to make one more revolution, right? What they have done, from here to here they have launched. Here to here only fuel was used. When it came to this position, then the engine was turned on again. Then from here to here, they shooted the satellite with the rocket. Once it reached that orbit, they have placed the satellite successfully. Instead of using the power from here to here, they have used this idea. This orbit is called as geotransfer orbit. Transferring means what? From one place to another place, from one vehicle to another, likewise only. From one orbit to other higher orbit, we can transfer the satellite. Geotransfer orbit, transfer orbit. Here, the perigee will be very less, 100, 200 kilometer. Apogee will be higher, very high, 35,000, 40,000 kilometer. Very less perigee, very high apogee. So that if you place it here when the orbit is shorter, you can shoot it back when the orbit is very bigger. That is the case. Geotransfer orbit. Geotransfer orbit. Okay, how many orbits do we have right now? First, 200 kilometer to 2000 kilometer, the basic important orbit. Majority of the satellites, normal observation satellites, student research satellites will be placed to this orbit only. This is low Earth orbit. Low Earth orbit. Which kind of satellites can be placed here? International Space Station, Space Telescope, Observation Satellite, Remote Sensing Satellite. Which cannot be placed here? Communication Satellite, DTH Satellite, Weather Observation and Forecasting Satellite cannot be placed here. But this drawback was overcome by the idea of placing more number of satellites in the low Earth orbit. The projects were Starlink and Project Kuiper. Starlink by SpaceX company, Project Kuiper by Amazon company. Okay. Those projects are important. If anything in news regarding that project, they might ask a question about the orbit also. Okay. Then we have medium Earth orbit. Distance 2000 kilometer to 35,786 kilometer. Medium Earth orbit. Which kind of satellites can be placed here? Navigation satellites. Navigation satellites can be placed in the medium Earth orbit. Then we have polar orbit. Polar orbit means pole to pole it is moving. Use observation only. We can observe the Earth in 360 manner. 360-degree view is possible in the polar orbit. Then we have sun synchronous orbit. Sun synchronous orbit 600 to 800 kilometer. This is also polar orbit similar to low Earth orbit. Sun synchronous orbit means satellite will be in synchrony with the movement of the sun. As the sun moves, the satellite will also move, so that observation is possible 24/7 by different places of the earth can be observed. For earth observation only. Major field of use is defense, right? Sun synchronous orbit. Then we have very important orbits, that is geosynchronous orbit, geosynchronous equatorial orbit. Both are at a distance of 35,786 kilometer. Geosynchronous orbit means this orbit can be inclined. This can be inclined to the earth. Which type of satellites can be placed here? Communication satellite. DTH is geosynchronous equatorial orbit. Communication satellite, weather observation forecasting satellites can be placed there. In geosynchronous equatorial satellite means just above the equator, just horizontally above the equator, this kind of satellites can be placed. Geosynchronous equatorial orbit, 35,786 kilometer above, 35,786 kilometer above. Geosynchronous equatorial orbit. Here, which kind of satellites can be placed? DTH. Normal communication satellites cannot be also be placed, but major use DTH communication satellites. Then we have the special among all these geotransfer orbit. Highly at the center we have Earth. Highly elliptical orbit. Highly elliptical. What is the use of geotransfer orbit? Transferring the satellite from the lower orbit or one orbit to the higher outer orbits. That's it. Mars orbiter mission used the geotransfer orbit. That's it. These are all the orbits which we have. Very, very important orbits are, one is low Earth orbit, the other is geosynchronous orbit. Okay. Any doubts? Very important thing. You need to know the different orbits and which kind of satellites are used here, right? Okay. In the next class, we'll discuss about the history of ISRO, Indian Space Research Organization, how it started, the starting days, the earlier missions. Later, we'll start the discussion about our launch vehicles, PSLV, GSLV, etc. launch vehicles, their specification, number of stages, etc. we'll discuss tomorrow. Okay. Thank you. I will check. Do you expect? No. Sure.